Is it at right place? Yeah, it is at right place. Okay. Definition: delete a node from end self. So the first thing first, let's check if the linked list is empty or not. If self.head equal to none, print empty linked list. Empty linked list. Else what we are going to do, we are going to delete the node from the end of the linked list. And how are we going to do that? Let's see here. Suppose there is a linked list like this: 1 1 pointing going to 2, going to 3, going to 4, and finally null. And this is our head, this is our head, yeah, and this is null pointer or none pointer. So we need to delete this node, right? To delete this node, we first need to reach this node by going sequentially from the head, like we did in the traversing case here, by choosing the temp node as our head and traversing until we reach the last node. I already explained you it in the previous video. Now after that, when we will reach the last node, we will just write delete last node. But the thing we need to do in this case is making this pointer point to null now, or point to none now. So the new linked list will be going to be like this: 1 2 3, and this is none. This is going to be our new linked list after deleting the last node at the end of the linked list. Now how we need to do that? For this, we need to reach the last node by using the temporary variable or temporary node we did like in the traverse function. And we also need this node, because by using this node we are going to make its pointer pointing to none, means there is no node after that, right? So we need basically two temporary nodes. Let's make it here: temporary node, temporary node 1, which will store the value of head, and temporary node 2, which will hold the value of the next element to the head. And we will run a while loop while temporary node 2 dot next is not equal to none, while temporary 2 dot next not equal to means while temporary node 2 is not at the last element. We are just going again and again. We are just traversing the linked list until the second node reaching the last element. So here, and temp node 2 equal to temp node 2 dot next, and finally delete temp node 2, yeah, and make temp node 1 dot next equal to none. So basically what is happening here, let's call temporary node 1 as tn1 equal to 1, and tn2 equal to 2. Okay, now what let's see the condition. Temp node dot 2 dot next is not equal to none, right? So what is after the temp node 2? After temp node 2 we are having 3 here. So it is not none, so the while condition is true. So we'll go inside the while loop, and what is written inside the while loop? It is written that temp node will become the next node, temp node 1 will become the next node, so tn1 will now become as 2, and tn2 will become now as 3, as easy as that, right? Then we will again check the condition. Is temp node 2 dot next not equal to none? So what is after temp node 2 dot none? What is after 3? After 3 we are having 4. Is 4 equal to none? No, 4 is not equal to none. So we will go inside while loop. tn1 equal to now 3, and tn2 will now become 4. By these statements, by basically jumping to the next element. Now what is after tn2 dot next? After tn2 dot next we are actually having null, and we have reached the null, so we will just come out of the while loop and we will delete tn2. So we will just delete tn2. So let's just delete tn2. Yeah, and tn2 is now deleted. Okay, and what is the next statement after that? The next statement says make tn1 dot next temp node 1 dot next equal to none. What is tn1? The value of tn1 is 3. Value of tn1 is actually 3 now, right? So tn1 will point to now nothing, it will point to now none, and our code is actually done now. That's just that how we'll delete a node from end and delete a node from beginning. Now another function we need to see is how to count number of nodes in the linked list. Definition: count nodes self, and in this we'll just first we will check if the linked list is empty or not. If self dot head equal to none, print. Actually we don't need to even do that, right? We will just go here at the initialization of the linked list, and we will make a variable self dot count equal to 0. So when the linked list was created and no node was created, I am making the value of node count as 0. Now every time I will add a node, I will increase the self dot head value. Self dot, I will increase the count value by 1. Self dot count equal to self dot count plus 1. So whenever I will add a node from beginning, I will going to increase this count value by 1. Whenever I am going to add a node from end, I am going to increase the value of count by 1. And whenever I am going to delete a node, I will decrease its value by 1. So -1. And also in this case we will deleting a node from end, self dot count -1, and we will just print the value of count here. Print self dot count, and it is done. Now let's try to run this code. Okay, so we actually made this linked list. We inserted 22, 24, 2222, 900 and 1000, and we are then traversing it, right? So let's just delete something from this linked list. My linked list dot delete a node from front. My linked list, let's again traverse it. Okay, and my linked list delete a node from the end. Yeah, my linked list dot traverse again. So actually we can see what is it is actually happening or not. And now let's run the my linked list dot count the number of nodes. So our code is almost done now. Now let's just run it and see what is happening. cmd cd desktop, go to the desktop, go to the linked list folder, cd linked list folder, and py main.py. There is some error. Okay, line 17, my linked is, oh shit, okay. Yeah, my linked list. Okay, now it is done. CLS and py. Now let's look what is happening here. So after this traversing, this is the first linked list traversing. We must add some stars here, so it will be help us to clearly identify what is happening. Star star star, and after this just star star star, and after this also star star star. Yeah, okay. So this is how the first linked list, when we travel 900, all these things are inserted. Okay, now delete a node from front. So what is the node in the front? The node in the front is 900. See here, 900 is actually deleted, and the linked list starting from 22222 now. After the delete a node from end, so basically 1000 will be deleted, and yeah, you can see here 1000 is deleted, and our linked list is 2222 24 22 and null. And count the number of nodes. There are actually 3 nodes, and we are getting the output as 3. So guys, this is mainly covering all about linked lists. In the next lecture we will see how to reverse a linked list, how to merge 2 sorted linked lists, and many other bonus questions about linked lists mainly asked in interviews. Thank you, and see you guys in the next lecture.